He's just being a team player. Okay. So rational numbers can be written as a ratio of two integers. I'll show you what that looks like in a second. Irrational numbers cannot be written as the ratio of two integers. Okay, it's important that we understand the difference between the two. The most famous irrational number is one that you are very familiar with. You'll see it in just a second. That can written. I'm a math teacher. What's that? No, I don't believe so. It's before that one. Okay. So let's take a look at what this is going to look like. Okay, so what we're looking at right here are going to be real numbers. It is my suggestion that you do, and I'm actually going to add one more. Okay, so real numbers are split up into two different groups. Okay, the group over here are going to be rational numbers. Okay, so all of the ones that we're putting in this group of circles right here, they are all considered to be rational numbers. So an example of rational numbers, we would have 1/2. You could have negative 2/3. You could have 0.3 repeating. And let's see, you could have a decimal, you could have 0.25, or 2.25, sorry, I read that terribly. Yeah. Do what? Yeah, less than 1.17. It just depends. Yeah. It's hard to say. So the next little tier down in rational numbers are going to be integers. You will see the word integers a ton on the state test. You'll see it on the benchmark that's coming up. Okay, what are integers? Anybody know? What are integers? That's true. Integers are.
Wait, don't say it, not yet. Oh, it's positive, negative whole numbers.
Positive or negative whole numbers. Yeah.
The negative 2 over is 3, right?
Negative 2 over 3. Okay. Integers are positive and negative whole numbers. So we could have -1, 2, -3. Okay. Those are integers.
Wait, how are those?
Okay. The next group would be whole Okay, whole numbers are basically every positive number and zero. So we'd say 0, 1, 2. I should have made those different colors. Oh no.
Oh.
Why did it come out like that? I didn't even draw that one. Maybe it's because I was zoomed in too far.
Oh, there you go.
That's better.
Yeah.
Okay, sorry about that. So, whole numbers again 0, 1, 2, all positive numbers and 0. The last one, does anybody know this? Natural. Okay, numbers that exist in the real world. What are the numbers that exist in the real world?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Just positive whole numbers. Okay, 1, 2, 3, 4, 5, so on. Okay, so these are all what kind of numbers? All of these, this whole big circle. They are all real numbers, and they are in which category of real numbers? Rational or irrational? Rational. Okay, so that means we will have irrational. Jet loves real numbers, in case anybody was curious. Okay. You get to make another one, yes.
Another circle. I can't even draw a circle.
There we go. Okay, these are going to be irrational. Yep.
Can I use this card to circle over?
Uh-huh. Irrational numbers are numbers. Irrational numbers are numbers that do not end, which is different than repeating. Okay? Repeating numbers are rational. If you look over here, we have 0.3, okay? Or negative 2/3, which is also repeating. And the reason being is because of the definition, okay? When you say a rational number is a ratio of two integers, 2/3 is a ratio, 1/3 is a ratio, okay? But those are repeating decimals, so they don't count as irrational. So examples of irrational, the most popular one is pi. Okay, other irrational numbers, we would say anything time. Come on, there we go. Anything times pi. So we could say 2 pi. We could say the cubed root of 7. Yep. Because there's not different categories of irrational. Irrational or just one group. Yep. No. Irrational. No, you're right. Irrational numbers don't repeat, but they're never ending. Okay. They are special. Okay. So all of these are your groups of real numbers. Okay. Your classifications. So make sure we get all those down. Yep. I guess I don't. What was I going to tell you?
Oh yeah, you were like, oh, remind me to tell you something.
Oh yeah, you didn't tell us.
Because I couldn't tell you on the video.
Yeah.
Oh yeah.
I think something happened where it was like someone went to the office and then after that it was like,
I'll have to think about it. I honestly don't remember.
yeah, I kind of missed it.
Come on, my pen is dry. Subset.
Nothing else is happening.
Yeah, I haven't shown you yet. Okay. So let's see if we can categorize these real quick, and then I'm going to let you move on to your next thing. This is all we have for for notes, okay? So we've got okay, A, B, C, D, and E. Okay, I'm going to give you the number. Okay, you need to tell me which group it belongs in. For some of these, you might need a calculator. Okay, now when it asks for a subset, what it's asking is what category, what's the smallest category that it could fit into, okay? Because technically you could just sort them as, okay, so not just the smallest one. You want to list as many categories as they can fit into, including all the way to the smallest one, okay? So if you have a whole number of 1 up here, then it would fit into natural, whole number, integer, and rational, okay? So it could fit into 4 categories at the most, okay? And you just want to sort those out. So the reasoning, okay, is like, so let's look at letter B, okay? Letter B is 0.25 repeating. What category is it going to fit into? Letter B is going to fit into, it's negative 0.25 repeating, okay? A repeating decimal fits where? In the rational numbers, okay? So I would write rational. I mean, as long as you know what it is, I don't care, okay? Your reasoning is that it is a repeating decimal. And repeating decimals are rational. Okay? Fill out the rest of that table. I'll give you about, I'm going to say 3 minutes. You should not need 3 minutes. making up the quiz from last week. I will be handing out Zap tickets tomorrow morning for either Wednesday or Thursday. Okay, so if you are someone that wrote your name up there, or you want to write your name on the Zap list to retake your quiz, make sure you write your name up there today. And then I will give you a Zap ticket tomorrow or Thursday. Don't go to Zap until you get a ticket from me, okay? Okay, how much more time do we need? Deal. Once you finish the packet, you may turn it in. Your word for today is multiple choice. Just doing some Pythagorean theorem and some square roots work. There is a back, so don't forget that. Please make sure you fill in your heading. Again, once you finish the packet from last class, please turn it in.
This one?
Wait, what did you say? I said once you finish the packet, please turn it in. Yeah.
Okay, mine.
All right, your solutions. All right. To the basket if you're turning it in, or the tray. There's a stapler over there on that counter. Yeah. Do what? Just detach it from the floor and then just let it hang because I'm going to use it for the next class. I'll get some more. You put what? It is a square root. I would say a square root like that doesn't end. Okay, would be like more accurate. Okay, there's the table. Okay, so once you get it filled out, you can check yourself.
Oh, I know. That's great.
I got some of them right.